Sometimes there's another law that's useful. And this law is based on the Pythagorean theorem, and it's a little more complicated to develop, so you can look it up or look in your textbook, but essentially what this law helps you do is the same scenario, except it's very useful when you don't have a pair of opposite data given. So if you don't have that proportion there and there's no way for you to find it, then this law is very useful. Now, the way it works is it's essentially like a Pythagorean theorem, except it's got this extra bit. So the angle here determines this bit here. Now this bit here usually was gone because cos of 90 is actually 0. So this is indeed a more generalized format of the Pythagorean theorem, because if you plugged in 90 as your interior angle of reference there, then that part would be 0 and you just have a squared plus b squared is c squared. However, this bit, you'll notice because this is less than 90, it's going to decrease it a bit. So that's just an intuitive explanation, but let's see how this works. What it tells us is that the diagonal squared, which is, remember, usually in the Pythagorean theorem, that's the biggest side, that's your opposite to your angle side. So in this case, this says theta, this says c, you could write this as a theta. And then it has a squared plus b squared, take away 2ab cos of the angle. Now, this can be rewritten, it's an extension of the Pythagorean theorem. It can be written in different formats. However, it depends on the angle that you're looking from. So if you're looking from angle B, then of course your answer is going to be the b squared equals a squared plus c squared minus the extra bit. And from A, it's going to be looking at a squared equaling the 2 beside it minus the cos. So it depends, like you probably just need one. However, with the labels might be different. So just remember that whatever the angle here is, the opposite side to that is what is it being equal to. So it's usually easiest to start with the largest angle first when using this. You'll just find that when you do a bunch of problems. So let's see how this works. Say we have this triangle, ABC, random triangle. We know A is 5, B is 7, and C is 10. But we don't know any of the angles, so there's actually no possible way to find the angles using the sine law, because we have no pair of opposite data to compare it to. We would just have the two top numbers, but we wouldn't have any of the angles. So this is A, this is C, and this is B in this case. And so therefore we need to use the cos law. And it's always a last resort. The sine law is actually easier to use, but sometimes you need to use the cos law. So let's start with the largest angle first. Let's follow that. And so the largest angle will be across from the largest side, which will be C. So let's go with that side. So what that tells us is the opposite to it, which is kind of like our diagonal, the 10 squared, is going to be equal to the side squares. 5 squared plus 7 squared, minus this factor of twice 5 times 7 times the cosine of the angle C. So now we have to go ahead and solve it. So usually your two places of interest are sometimes you have a variable here, in which case it's easy to just plug through that, and sometimes you have a variable here. So that's a little more work to solve. So let's look at how that works. 100 equals 25 plus 49 minus 2 times 5, which is 10, times 7, which is 70 cos C. And so we just want to move everything away so that cos C is alone, and then we can take inverse cos once we get it alone. So let's go 100, take away 25, take away 49, that's 26. equals -70 cos C. And then we want to divide both sides by -70, leaving us with cosine C is equal to 26 over -70, which is -0.3714, etc. Try to keep it as exact as possible, or store it in your calculator, so that now what you can do is take the cos inverse to find the angle. So the cos inverse of the answer is 111.8 degrees. And in this case, we want that. We don't want the reference angle because this does look like 111.8 degrees. So now that we know that, we can find the other bits, and we can even use the sine law because it's a little simpler to use for the other bits. So we know 10 over sine of 111.8 will be the same as any of the other proportions. So let's find b. So that's going to be 7 over sine of b. So that means sine of b will be the cross multiply divide of that. So then we'll just have to find the sine inverse of that. So 7 sine, and I'm just going to type the answer into my calculator so that it's exactly the same, and I get 0.649923, and then take the sine inverse of that answer, and that should give me 40.5. Now if you've been rounding, it might be a little off from that. So that's our angle here, and the last angle we can find by adding everything up to 180. So 180 take away 111.8, take away 40.5 will give us 27.7 degrees. And so we found all the missing pieces. Try this one out, see if you can get it on your own. Triangles are very useful in many different places, so we're just looking at random triangles. You can apply it to anything in life that you like. So we've got B as a pretty big angle, so let's put it here, 110. So that's going to be little b. We don't know that, so that's not a pair of opposite data. We also know C is 35 and A is 20. So I'll put the 35 on the longer one, so that's C, so therefore that's C. And A is 20, so that's A. Great. So again, we have no opposite data, so we need to use the cosine law to unlock this problem. So usually we start with the biggest angle, and in this case, this is the best thing to start with anyway, because you have the two sides and you're equaling everything to the opposite side. So b squared is equal to 20 squared plus 35 squared minus the twice 20 times 35 bit times the cosine of 110. In this case, it's a bit simpler to solve than the previous usage of it because we just need to find b, and we don't need to do all that algebra to unlock that. So we have b squared is equal to 20 squared plus 35 squared, which that part gives us 1625, minus 2 times 20 times 35 cos 110, which is negative 478.828. Continue, so add the 1625 minus that answer, which is really adding them, which gives us 2103.828, and then square root it, giving you 45.87. So that tells us b is 45.87 in this case, because those are rounded. Let's just round it to 46. Okay, now we need the other angles. And so because now we have a pair of opposite data, we can find the other angles. So 45.86, just 45.87, I'll just keep it precise, over sine of 110 is going to be the same as, let's say, the C proportion. So that'll be 35 over sine C. So that becomes sine C equals 35 times sine of 110 divided by 45.87. Try that out. And that should be giving you 0.717. And when you take the sine inverse of that, you should get 45.8. So if we know this is 45.8, then we can subtract from 180 to get 24.2 as the other angle. So make sure to put your degree symbols on the degrees and you're set. So let's look at an application of this. Given that, you know, anytime there's a direction given with an angle, what that means is you're looking at the terminal side of the clockwise angle from the north direction, meaning if that's north going up, then the clockwise direction of that angle is the angle given. So in this case, you have these angles given as directions. So that's going to help us with that bit. Okay, so two planes leave an airport at the same time. Let's say our airport is right here. And there's north. And they fly for 2 hours. So remember that 2 hours just tells you that that's going to help us multiply the speed to get the distance. And plane A flies in the direction of 125 degrees. So that means 125 is approximately there because it's less than 180. So that's 125 degrees. And it's flying at 425 kilometers per hour. For 2 hours is going to be 850 kilometers. And that's plane A. And plane B flies the direction of 230. So that's bigger than 180, but less than 270. So it's not quite at the next bit there. So that's 230 for that total angle there. And it flies at that direction 450 kilometers per hour for 2 hours, which is 900 kilometers. And that's plane B. How far apart are they at this time? So that's our x. So let's redraw this scenario. We've got this triangle. Now what's this angle? Well, it's whatever 230 is minus 125, which is 105 degrees between them. This one's gone 850 and this one's gone 900, and we want to find x. So in this case, this gives us a nice usage of the cosine law because we don't have a pair of opposites, but we need to find the side. So remember, the x squared is equal to the side squares, 900 squared plus 850 squared, just like the Pythagorean theorem, but you're taking away twice the a times the 850 times the cosine of 105. So we just need to find all that, plug that into your calculator, 900 squared plus 850 squared minus twice 900 times 850 times cos 105. And that should give you this big, huge number. And square root that, and you get 1388.7 kilometers. Fancy that.